Hello, my name is Akshay Tangsale, and you're watching the pre-lecture video for week 2 of Material Energy Balances unit. Today I will talk about what we covered in week 1 and also look forward to what's coming up in week 2. So in week 1, we talked about the logistics of this unit, mainly looking at the timetable, the assessments, and so on. One of the things for you to do is to look up the timetable for labs and enroll for a time that is suitable for you for either air conditioning lab or the bicarbonate decomposition lab, not both. Also sign on for a HYSYS group assignment. Remember, it's best to sign on in a group in which you have team members in the same computer lab allocate grouping that you will be doing the labs in. It will just make it easier for you to do the assignment with your group if they are all in the same computer lab. Also note the deadlines for other assignments and tests so that you can study accordingly for those assignments and tests as they come. Keep up with the pace of the subject. Another assignment for this week was to complete the concept map quiz. This quiz will be open until Friday, 1st of August. So please make sure that you complete that before that time. During the lectures, we went through chapter 2 of Felder-Russo textbook, and we looked at unit conversions. Mainly, we concerned about converting units from American engineering units to the SI system that we use. We also looked at significant figures and why it is important, and how to carry forward significant figures when you're doing arithmetics. We also looked at some process variables that we will use in mass and energy balances. Process variables like mass, mole, mass flow rate or volumetric flow rate, and also molar flow rates. We looked at an example of conversion of mole composition to mass composition, and you've got a homework assignment to do mass to mole composition conversion. I will give you step-by-step instructions on how to do that in case you find that difficult. We also start tutorials in week 2 in which we will cover unit conversions mainly. So let's look at how to solve the homework assignment on mass to mole composition. The first thing to do is choose a convenient basis if a basis is not given, like in this problem. So if a basis is not given, choose 100 gram as a basis or 100 kilogram. The next thing you would do is multiply the mass fraction with the total mass so that you can get the mass of each component. Then you would divide mass of each component by its molecular weight to get the moles of each component. You would add all the moles to get the total moles, followed by dividing each mole by the total moles to get the mole fraction of each of those components. To validate your answer, you should also add all the mole fractions together and check if they come to 1. Remember, mass fraction or mole fraction of any given stream should add up to 1. Now we look at what's coming up in week 2. So in week 2 we will finish the chapter 3 that we are on at the moment. We will look at pressure measurements, especially looking at fluids and how head of fluid creates pressure at the bottom of a container, and how we can use pressure differences to calculate flow rates. We will also look at temperature measurement, which is a very short section. There is no calculation in it. This is for your information how to measure a temperature. Then we move on to chapter 4 of Felder-Russo textbook. This is the main chapter of material energy balances. In fact, this chapter talks about the material balances in general. Okay, so this forms the basis of all of this unit. First, we will define what are the types of processes: batch, semi-batch, and continuous process. We will look at general balance equation. followed by methods for drawing process flow diagrams. It is absolutely essential to get the process flow diagram right, because more often than not, if you get the process flow diagram correct, you will solve the problem correctly as well. We will look at degrees of freedom for any given problem and use degrees of freedom to assess whether a problem is underspecified, overspecified, or just right for solution. And finally, I will talk about multi-unit processes, in particular looking at operations like bypass, purge, and recycle, and how we do material balance across these operations. And lastly, I want to talk to you about the homework reading for week 2. In Felter and Rooster textbook, you should read section 3.4, which talks about pressure measurements, and in particular look at example 3.4-1. And then looking at sections 4.1 to 4.5, and in particular paying attention to the examples 4.3-3 and 4.4-1. So hopefully you will have these done before you come to the lectures in week 2, and I'll hope to see you there. Bye bye.